right. Hi, everyone. So my name is Jules Villard, and I'm here today to talk to you about Infer. So there was a session earlier at noon, but in case you guys missed it, Infer is a static analyzer that finds bugs in your code by just trying to understand what the code does on its own and looking for certain classes of errors. And this classroom is going to be mostly me playing with Infer, showing you different kind of things it can do. And so hopefully you can get inspired to see how it could help you with your projects, finding bugs there and fixing them. And with me today is Jeremy, who's standing over there and is helped me prepare this presentation and is going to help me field questions. And speaking of, by the way, feel free to interrupt anytime to ask questions. It's going to be much less boring this way. But if you do ask a question, I'm going to ask you to raise your hand, please, so that someone can come and bring you a microphone, because this is all being recorded. All right, so let's start right away. OK, so this is about code. So let's the way Infer works is so here's a simple project with just one simple file, which is this program. It's pretty dumb. It dereferences null straight away. So what does Infer do on this? So what you need to use Infer is you need a way to build your program. So in this case, you just call clang, for instance. And to use Infer on it, you just on many build systems, it's enough to just say infer ---- the build command that you would use. And if you do that, then it's going to look at the code. And here, Infer finds that there's a null dereference error. And it's saying pointer p here, which was last assigned on the previous line, could be null, and is dereferenced. So all right, pretty straightforward. That was just to give you a very quick idea. So where can you get Infer? So it's open source, available from fbinfer.com. And if you click on Get Started here, it will bring you to this page. There's a bunch of different ways. On OS X, you can type brew install. There's some Docker image. And maybe right now, we just released a new version, so that hasn't made it to all the channels yet. So the best is to go to the releases on GitHub and get the binaries we published here for Linux and Mac. So if you just download that tarball, it will give you can get started right away using Infer. OK, so I'm just going to go through a few examples of different kinds of issues that Infer can find and how to understand them. So let's go to the next one. OK. So if I open the next project, I have this file. And OK, can someone tell me what's wrong here? Probably not, because we have no idea what these functions we're calling are doing. But let's ask Infer what it thinks. So this one compiles with make. So I can do just make. And I should be able to do infer ---- make. But oh no, it says nothing to compile. When make clean first, yes. So you need to always remember to clean your project. So Infer finds two problems with that example. One is a memory leak, and another is a null dereference. And so sometimes if you're in the zone, you can sort of understand straight away, oh yeah, I forgot to check for null or things like this. But sometimes it's useful to look why Infer thinks there's a problem. So for this, we have a tool that will explain the reports to you. Just type infer explore. It's going to say again what bugs it found. And then you can select, oh, I want more information about bug number 1, for instance. And it spits out this trace of Infer going through the code and how it noticed there was something wrong. So we could look at this in the terminal, but I like to look at this inside the editor. So the messages are displayed in a way the editor can understand it. So if I just pretend I'm compiling this, Emacs, for instance, here understands this trace. And I can just jump through each step in my editor, which I find convenient. OK, so here it's saying, again, there was a problem at this line here. And if I step through, I'm going to see what Infer did. So it started here, it stepped through here, and then there's this allocate in function, and Infer is going to step through that. It's in another file, so we jump there. And here we see, oh, right, allocated is just calling malloc, and then returning. And then this set function is also in this file, and it's just straight up dereferencing p. And so malloc can return null, so that could cause a null segfault here. So I have to do if p is not null, set the thing. And then if I run infer again, aha, the null pointer exception is gone. There's still a memory leak. I can fix that pretty easily now that I see what's going on. And bang, no issues found anymore. OK, let's look at something else. So this example, I should do that here. So in this example, this is a Java file that it's a pretty standard thing you want to do. You need to, this function opens two files, and it reads from one and writes whatever it read into the other. So the way you would do this in Java is you allocate these two streams, then you do your actual thing, and then because you're wary about leaking resources, you have this finally block where you carefully close them. So that should work, right? Let me. And if I run infer, it says, oh no, there's a resource leak. And actually, the message says, this out file thing here could leak. And note, there's a potential exception at line 22. Line 22 is this line, which is the one just before we try to close out file, we try to close in file. But the thing is, in Java, this can throw an exception, and then you didn't close out file. So there you have a resource leak. And so that's quite common. And a common way to fix that in Java, at least, is in Java 7, you have this new syntax that takes care of all the resource management for you, and that's probably what we should have used here since we have several resources. So this try with resource thing, it just creates the two resource, and you have your business logic here, and you don't need all this finally closing. This takes care of it for you. Right? Any questions so far? All right. So these were some basic examples of bugs. Now let's go. One of the cool things Infer can do is it find race conditions in your code. So here we have, OK, let's open this project. It's 3 Java files. There's some client, some accounts. And if I run Infer on it, it says everything's fine. But, oh, sorry. So one thing I can do is now I want to tell Infer, wait, but this thing can actually run in a concurrent context. So please be extra careful to check for data races. So the way I would do that is, for instance, I can annotate classes with thread safe, which is something Java programmers do sometimes. Except usually nothing checks anything about them. It's just more documentation. But with Infer, you can actually give meaning to that. Infer is now Infer will know that this is supposed to run in a concurrent context. So it's going to look for data races. So what's a data race? A data race is when there are 2 accesses to the same field of an object or the same object. And at least one of them is a write, and at least one of them happens outside of synchronization. So you forgot to lock one of the 2 accesses. OK, so now I can check my project. Does Infer think this is safe? It says, no, I don't think this is safe. And here's something a bit subtle. So it's saying you're calling into an unsafe interface. And we could read that, but basically what it's explaining is that here, this account class is not an actual class, it's just an interface. And so if I open it, it's just this signature, and Infer has no idea what the actual implementations of this interface are. It cannot know all the implementations. So it's asking you to annotate the interface itself with thread safe so that it can check that the implementations are all thread safe too. So that's what it's explaining here. It's just saying, hey, write thread safe here. So OK, let's do that and run again. Aha, so now it's finding some actual data races thanks to the annotations we added, saying you have a thread safety violation in the implementation of that interface here in account implementation. And it knows that this is supposed to be thread safe because it's implementing this account interface we just told Infer was supposed to be thread safe. So what is it saying? It's saying this deposit method here, it's writing to this field mbalance outside of synchronization. And that's not good because it could race with itself, for instance, and generate a data race. So what we're going to do is annotate this with synchronized and run Infer again. And it's still not happy because we also, this other function also writes outside of synchronization. So how can I see that? So here I'm going a bit fast, but maybe I didn't quite understand what Infer was saying, and I want to look at the traces to debug and see where I should add annotations. So another way to explore the results, if there are too many, for instance, is to generate an HTML report. So in this case, with just passing --HTML to this Infer Explorer command, and then you open it, and then you see all the bugs, and each of them has this little trace. And I need to make this way bigger. And so, OK. So here is saying, so the data race traces will always look like this. There will be two traces that are accessing the same thing, and one of them is outside synchronization. So there's a read trace here coming from deposit, which is synchronized, but deposit is accessing mbalance inside synchronization. And then the second trace is a write trace. It's going from the other method, withdraw. It's also calling this add to balance method that ends up modifying the field. And so they're modifying the same field, and the first one is synchronized, but the second one is not. So there could be a data race here. So I need to also tell Java to take the lock before whenever someone calls withdraw. And now I run Infer again, and it says no issues found. So the point of this example is you can start from a code base where you want to turn things into concurrent. You want to make things more concurrent, for instance, but you want to do this with some confidence that you're not going to introduce data races. And so you can have Infer help you write safer code by checking that everything is thread safe as intended. Another way to trigger Infer to report on these things is you don't even need to add these thread safe annotations. Usually, usually when you're writing concurrent code, you will already have some synchronized accesses here and there, and Infer takes that as a hint that these are supposed to run concurrently, right? Otherwise, you wouldn't have taken any logs. And so it will not report. Oh, yeah, because this one is actually thread safe, all the methods are synchronized. But if I forgot one, then it's going to yell at me because it noticed that this one is synchronized and is modifying mbalance. But this one is also accessing mbalance, but it's not synchronized. So something is wrong here. Either you forgot to synchronize or you put one too many. OK. Let's see another example of going from an existing code base and trying to make it safer and safer. So in the first couple examples, we saw Infer finding null pointer bugs. And you might do that for a while, but at some point you might get tired of this and think, okay, but can I actually get rid of all the null pointer exceptions in my Java project? Because people now are starting to get used to better languages like Kotlin that actually provides you with this safety guarantee that there will be no null pointer exceptions. And you can get the same thing in Java with Infer. So if I go to this other project, actually, so there's another mode of Infer called Eradicate only, that will check that you've annotated your project correctly with nullable annotations. So what does that mean? Let's take a look at what Infer says in that mode. So first, it says only one warning in library.java. Check. It's saying field library.t can be null because I saw it get null in this call here, but it's not annotated with nullable. So the discipline is anytime something can get assigned null, you have to mark it nullable. And this allows Infer to check subsequently that every time you look at this, you make sure to null check it. Okay, now we get a different error saying, oh, this get method, it might return null because here it's returning t, but you didn't annotate this with nullable. Okay, let's keep playing the game, adding nullable wherever Infer says I should. And then it says client.java, aha, this time it's found a nullable dereferencer. So actually, that file here could accidentally dereference null. And now Infer can see that very clearly because everything has been annotated. So what is it complaining about? It's saying lib.get could be null. So we need to check that. So what we would do here is we would put this in a local variable. And then we will, for instance, if t is null, I hope I can write Java. No, null is lowercase. Then return default. Otherwise, return t.toString. Is that Java? I hope it's Java. Yes. All right. So now I've gotten rid of all the nullable errors in my code. And this time, Infer not finding any issues is giving me a much stronger signal because it's running into this eradicate mode. It's giving me a signal that I have no null pointer exception in my project. That's much more powerful than just looking around for bugs. OK, so these were all toy examples I made up. So what about a real project? So for this demo, we're going to look at a small project called Nailgun. So let me show you the page. It's also a Facebook project. Well, actually, someone else wrote this originally, but Facebook is maintaining it now. It's also on GitHub. It's a project to make your Java processes long-running so that you don't pay the cost of starting Java, the JVM, every time you launch them. So let's go there. Nailgun, and it builds with Maven. And let's go straight into the server part. There's also tests and stuff like this. But so it builds with Maven. And again, Maven is slow, so let's kill it. The way to run Infer on this project is just you add infer -- in front of your compile command. And you probably need to clean in the meantime. And here I've already set up this eradicate mode in the configuration of Infer. So it's giving me all these eradicate warnings. And the way I did that, I didn't need to pass it on the command line because I wrote an infer config file, which is also a good way to configure Infer for your project. You can store all your options in there so that you don't have to remember them. So here it's saying eradicate should run. By abduction shouldn't run. By abduction is this other mode that's just looking for null dereference errors, but doesn't care about nullable. And then this race detection analysis is also enabled. And then there's some configuration pertaining to configuration of eradicate just to make this is mostly to make this less noisy on this project because we haven't actually added nullable everywhere we should have, but we got to a reasonable point. So here that's the project without having added any nullable annotations. And we can see there's like quite a few. I mean, this project doesn't follow nullable, so there's lots of places where Infer thinks things shouldn't be marked nullable, and that's what it's saying here. And we could go through the same game we just went of following Infer's recommendation of, hey, this field is null here, so you should probably mark it nullable, etc. And if we do that, we go to so we can do that for a while, and we've done this offline and got to a point that's a bit more interesting where we actually find some errors. So I just checked out a branch where the difference is we've added nullable in quite a few places. And if I run Infer on that version, then it should give me much less bug reports. There we go. So now there are only 4 bug reports. 2 of them are race conditions. Aha, we have to check that out. And there's one place where it thinks I should add a nullable. 2 places where it thinks I should add nullable. OK, let's look at those. So first warning is A in that file, ng communicator, which I forgot to open. There's a nullable missing on this stdin file. Let me just copy that. And if we add this here, OK, so this one is set to null here. And it looks like Infer thinks it should be nullable. If we add this nullable annotation, what does Infer say next? So as you can see, even in this it's a small project, but you can see Infer runs pretty fast. It's faster than the compilation time here, for instance. So now it's saying, aha, this generated this new warning here in ng communicator that at this line here, you could have a null dereference. And indeed, this one looks actually pretty legit. This is dereferencing stdin, and it didn't check for null. So probably the code is wrong here and should be changed to do some more null checks. So annotating with nullable like this allowed us to eventually find some bug. And if we look at just before I leave you, let's look at this thread safety violation, because I think that one is real too in alias manager. So see, we added a bunch of nullable to the project here. So get alias, it's saying get alias reads without synchronization. Yeah, true, it reads aliases here without synchronization. But look at this just a few lines above. This guy remove alias is synchronizes to do the remove. So probably we want to do the same here. This looks legit too. And some people who know Java better than me tell me that it's probably not a good idea to synchronize on the same object that you're accessing, but I'm not sure. OK. So when we run Infer again, now we solve all the 2 races, actually. They were both referring to the same issue. OK, so that's pretty much all I had. I think we're running out of time, too. So do you guys have any questions? Yes? A mic here, please. Sorry, I wait for the mic.
Sorry, is there any support for Swift at all?
Aha, no, sorry, there's no support for Swift yet.
OK. But will there be plans of support for Swift?
We're not working on this at the moment.
OK.
Maybe in the future.
Same line of questions, like support for Kotlin.
So there's no direct support, but we start from the Java bytecode, and I'm not sure how close the Kotlin bytecode will look to a Java program, but you could totally try running Infer on the Java bytecode produced by Kotlin. We haven't tried it, so I don't know.
Yeah, any integration or plugin into IDEs like Eclipse, NetBeans?
Not at the moment, but that's something we're definitely looking into. So as you can see, it takes a bit of time to run, so it's usually a bit too slow to run in the IDE, especially on larger projects. But yeah, definitely something we're looking into. But not right now. There was a question in the front. So hold on.
Can Infer check multiple projects at the same time and cascaded subfolders?
Sorry, say that again,
Can you
please?
check multiple projects at the same time?
Multiple projects at the same time.
Dependence. They may be dependent.
Well, so as long, if you can check them individually, or I mean, you can also, you can check them at the same time. You can capture. So there are several phases in the run, and you can actually run the capture phase where Infer collects all the source files. You can run that independently from the analysis phase where Infer analyzes them. So if you have several projects that depend on each other, you would probably want to first capture all the projects and then run Infer on once it has all the files together.
Not one command, multitask.
Sorry, what?
Not one command, just multitask, right?
Yeah, you would have to run a couple commands.
Oh, thanks. Thank you.
Any more questions? All right, well, thanks a lot for your attention.